So on a site like this, I'm at a mining site called Lucky Boy. We want to do some radiation mapping. So if you're new to radiation mapping, we're just going to give you an example of how you would do it. Typically, if, for example, I'm carrying a detector in my backpack, which I'll be doing in a minute, I'm going to be walking parallel grid lines. So I might choose to walk north-south or east-west, or any kind of orientation where my lines are walked parallel. And I'm going to walk lines which are something like 2 meters or 5 meters apart, depending on the sort of resolution that I want to get. Now, if I've got the detector in my backpack, so the detector will probably sit just above waist height, then the actual area of ground that I'm detecting is probably on the order of about 1.5 meters to 2 meters diameter. So this is why typically we'd want to walk the tightest possible line spacings that we can. So 2 meter line spacings is good if you have the time, but also if you're working on difficult terrain, then it's very difficult to maintain a correct spacing in a correct line. And this is why we do it with drones as well. So we're going to do a little example where I'm going to walk an area as best as I can. I'm using an AARM radiation mapping system from Imitech, and then we're going to repeat the exercise in the air. Obviously with the drone's going to fly a little bit higher, probably something like 2.5 to 3 meters, and we'll actively compare the data to see how they look against each other.
Moving to start point.
So we've completed the exercise, and what we can see is the results are really nicely comparable. Now, this was very easy for me to do the mapping because I was doing it over a very flat area, but if I had to do this over hilly terrain, if I had to do this in a quarry or an active mine site, that would be nearly impossible. And what we can see from the data is that the drone data is very good in comparison to the data that I recorded myself. And that shows us that actually drones, very much for radiation mapping applications, are better than human beings because they can work irrespective of the terrain. They can also able to hold their flight lines very, very well, whereas human beings are prone to error. So this is why in a lot of the work that we do for mining exploration, for mine permitting, for mapping of nuclear sites, where we can, we always use drones.